found in the nucleus, represented by letter Z. Mass number is the number of nucleons found in nucleus. It represented by letter A. The number of neutrons represented by letter N, that equal to A minus Z.
Mass defect is the difference between the rest mass of nucleus means contained of neutron and proton, and total of the rest mass of the isolated individual nucleon. Mass defect means delta M equal to isolated particle minus
Nucleus.
Binding energy of a nucleus is the amount of energy required to take all the nucleons from the nucleus apart so that they become isolated particles. So the formula for binding energy is E equal to delta M, means mass defect, times C square. C means speed of light. We go to binding energy over nucleon, or E over A. So this is the graph binding energy per nucleon plotted against the mass number A of all the elements. Initially, the curve increased for light element like helium, lithium or carbon. The binding energy per nucleon raised from 1 MeV to 8 MeV. For the moderate weight element with a between 50 to 80, the binding energy nucleon range 8 to 8.9 MeV. The elements are very stable. After A equal to 680, the curve dropped more faster. Heavy element with A between 200 and 240, the binding energy per nucleon is between 7 MeV and 7.5 MeV. This element is unstable and radioactive. It means that energy per nucleon is insufficient to bind 200 of a nucleon together to form a stable nucleus. This nucleus tends to disintegrate.
Iso mean same. Tops mean types. So isotope means same types. Top have same atomic number but different mass number.
This is the structure of the mass spectrometer. The function of the mass spectrometer is to detect the presence of isotope of the gas. One of the structure of the mass spectrometer is the tube T. Tube T contains a gas at low pressure. Besides that, tube T also contains a cathode and anode. This is an anode and this is a cathode. And tube T also have a pair of parallel metal plates, P1 and P2. P1 and P2. Besides this evacuated chamber, uniform magnetic field is applied in this section to distinguish between ions of different masses. The last one is the photographic plates. Ions of the gas eventually fall onto it after travel in a circular path. Electric potential difference, which several kV is applied across cathode and anode. Ion accelerated from the cathode to anode. Ions travel with range of velocity enter the space between the metal plates P1 and P2. Electric potential difference is applied across these metal plates to produce a uniform electric field. At the same time, a uniform magnetic field is also applied in space between the plates. So there are two forces acting on the ions, which are electric force and magnetic force. After enter this section, ions travel in circular path and then fall onto the photographic plates. The radius of the circular path will determine the type of the isotope of the gas ion.